Hi everyone, Cody Don here and welcome back to Cody's Lab. Today I have Andy from How to Make Everything and I'm going to help them make some glass. I wanted to get some potassium nitrate, but unfortunately my knitter bed is, well, it was eaten by the cows. They literally ate it. Turns out chicken poop tastes a lot like corn and cows love to eat it. So today I'm going to be making some nitric acid from the air, and I guess I'll react it with some calcium to make calcium nitrate, which will work just as well as the high temperature oxidizer to burn out impurities in the glass. So I got a little pH gauge here, and a shot glass full of water. Looks like our pH is just about neutral, which is excellent because that is pure water. And I'm just going to pour this over here into this glass jar, just like that, and I'm going to insert these electrodes which are coming off of this high voltage power supply. There you go. It's got a little spark going. So what's going on with the spark is it's producing an environment which is so hot it turns the gases in the air into plasma, and when they cool down they reorient themselves and basically it stirs everything up, so instead of having N2 and O2 you can wind up with N2O or NO or all sorts of different molecules, including ozone. But fortunately for us, the ozone will actually go into oxidizing the nitrogen oxides further into the nitrates. And of course, all that will react with the water, forming nitric acid. Alright, it's been going for a few minutes. Let's turn this off. Let's see if we can mix the water in with the gas that's in the jar now. See, it's got a slight brown tint to it. Okay, let's open this up. So pour the water into this little shot glass again. Let's see how the pH is doing. 5.7, that's just after a couple of minutes worth of running. So, yeah, to produce a whole lot of nitric acid, it's going to take a while, but we can do it this way. Alright, so here we are. It's not going, so I don't know exactly how long this thing actually ran for. I think something happened to my power supply. Anyway, let's open this up. Let's see just how much acid we were able to make. Let's turn this pH meter on. Pour this off into the little flask here. I'm going to drop some out. Oh, well. So that looks like a pH of 0.8. If memory serves, that means it's just over 0.1 molar in concentration, which means we don't got very much nitric acid here. That'll probably make less than a gram worth of potassium nitrate. Well, it's better than nothing. So there's Stansbury Island and the Great Salt Lake. And right down here, some calcite crystals. See that? Let's break a couple of these out of there. And make a lime out of those. So we need some calcium oxide, or lime, and one of the best ways to do it is to take some calcite, and I'm just going to bust this into little pieces, and we're going to roast it using my new furnace here. Alright, that's probably plenty. I don't think we're making more than about a pound of glass, so let's get this cooking. Yes, I am using a measuring cup, but I actually bought this one this time. It's just a stainless steel crucible essentially. I'm just going to set it inside of here. Bring it up to about 2,000 degrees for an hour or so. We should have some lime. Alright. So we're up around 2,000 degrees and it's been there for over an hour. Let's open this up and see how it looks. Whew. It's warm in there. Alright, let's pull it out of there. Oh, the oxide's flaking off, getting everywhere. Let's see if this strong magnet can pull that out of there. Oh yeah, no problem. No problems at all. Now we got ourselves a bunch of burnt lime. Calcium oxide. No, don't stick to that. The cool thing about this is it's now incredibly brittle and easy to break up into a powder. Alright, so I've got some of the quicklime that we've made in this jar here. Now, what are we going to use this for? Now, we're obviously going to be using it to make glass, but there is a couple of reasons I've made this. First of all, we're making soda lime glass, and this is the lime in soda lime glass. This is needed to help make the glass so it's not water soluble. But also, the source of soda, the sodium carbonate, comes from a well, what we're using for this set of videos is coming from a lake in Wyoming. It's a natron brine, which is great because it's almost pure sodium carbonate in water, but it does have a contaminant of sodium sulfate, which is a problem, especially for glass making, because the sodium sulfate will break down over time and release gas and make a metallic smelling vapor over time as it evaporates. And it will take a very, very long time to break down the glass, and it'll probably continue making bubbles for basically as long as we could possibly heat it. So I need to find a way to remove the sodium sulfate from the brine. And to do that, I'm going to be using this lime. So first of all, to test to make sure this chemistry works, I'm going to make some sodium sulfate. That's why I've got some bicarbonate of soda here. Now this is just a test. This is not what we're going to be using for this, but this is just to make sure that my chemistry works. So I'm going to add just a little bit of that, like that. We'll stir this in until it dissolves. And that'll give us our sodium carbonate solution, and to convert that into a sodium sulfate solution, I'm going to neutralize the carbonate using some sulfuric acid, concentrated acid that I've got here. And this is forming sodium sulfate and carbon dioxide, which you can see in the bubbles. Alright, so now that this is neutralized, it's time to make the calcium hydroxide. So we'll take our lime, and I've got some water here. So you can see the temperature of the water right there is about 24 degrees Celsius. Let's actually remove that for a minute. And let's dump in a small amount of our calcium oxide here. When we roasted the calcium carbonate, CO2 was released, but heat was also absorbed. When we add this to the water, the calcium oxide will react with the water, forming calcium hydroxide, and will release lots of heat. If we focus on the thermometer there, you can see the temperature is now over 40 degrees Celsius. So quite a bit of heat was released when that reacted with the water. In fact, calcium oxide like this, or quicklime, has been used as a way to heat up self-heating packets. So now that I've got the quicklime reacted with the water, the heat's been released, I am left with some calcium hydroxide mixed with water. Now the calcium hydroxide is poorly soluble, so you can see that most of it is actually kind of settling out here. And that white material that's settling out is called sacked lime, or calcium hydroxide, or essentially what you would buy at the agricultural store to put on your garden. Now, interestingly enough, its solubility can actually be increased by cooling off the solution. So I will do that by adding some ice here. When I'm doing this with the actual natron brine, I don't think I'm going to worry about the solubility. I'm just going to add in an extreme excess of the calcium hydroxide. Most of it will just settle out of solution and it'll react as needed. As the hydroxide reacts with the sulfate, it'll, more will dissolve in. So very little of it will be left in the remaining solution that I don't think I'll have to worry about it. Alright, so I've let this settle out a little bit. Let's pull some of this off. Let's add it to our sodium sulfate solution and see if we get any sort of precipitant. Alright, I didn't see anything. That's to be expected. Sodium sulfate is actually somewhat soluble, so we're going to have to just keep adding it until we get some amount dropping out. Yeah, it's definitely getting cloudier. See, the calcium sulfate is beginning to precipitate out of the solution. Also, the amount of calcium hydroxide I've added is actually not that much, because it's not very soluble. I've only got a little tiny bit of hydroxide here. Like I said, when I add the solids in, it'll be much more effective. Now, some of you that know a bit more chemistry may have seen a bit of a problem with this. You see, calcium carbonate is much less soluble than calcium sulfate. What I'm going to do here is drop all of that out. We're going to convert the sodium carbonate solution into sodium hydroxide, which we can then react with carbon dioxide later to form the sodium carbonate once again. Also, sodium hydroxide is actually, it's equivalent to the sodium carbonate. They both do the same thing in the glass mixture. One just releases CO2 and the other one releases water as it breaks down. So now you can probably see that the calcium sulfate is indeed settling out. So this is a way to remove it from solution. It won't remove all of it, but it'll remove it down to a point that we can use it. Now, I wanted to show you guys something while I'm here. Let's check the pH of this solution. Looks like around 12.3-ish. Sounds about right. So this is the milk of lime pH. Now let's make us another solution of baking soda here. Just mix in a little bit, stir it up. Let's actually pour off most of this. I don't need that much. Alright, so let's see the pH of this. It's probably going to be all out of whack because it's hot. Looks like 8.3. Alright, so now let's mix them together. Give this a stir so we can get the good solid particles in there along with it. Alrighty, mix that up. Now, should see a little bit of fizzing. Yeah, there's a little bit of fizzing going on. Alright, so it looks like the reaction is complete there. Now let's check the pH of it. Alright, yeah, it's already higher. 12.8. It's not a lot higher, but you can tell that a stronger base was formed. And in case you're wondering, yes, this is how lye is made from wood ashes. You react the sodium carbonate, or potassium carbonate, whatever you got, with calcium hydroxide. Calcium hydroxide will form the calcium carbonate, which will settle out eventually, leaving the alkali hydroxide in solution, which you can make soap out of. But that has nothing to do with making glass. Alright, so I think that's all of the contribution that I'm going to be providing to these videos. The nitrates that I've produced will be used to help burn out anything that would cause the glass to turn, say, black. I've produced the calcium oxide, which will be used to help the glass be insoluble, and I've purified the soda so that it doesn't continuously form bubbles as we're heating it. I think I will also be helping to purify the sand. But really all I can do without some major chemical processing is maybe a gravity separation to separate out the magnetite and hematite, which the hematite is not magnetic even though it contains just as much iron and will really change the color of the glass. Even still, I think there might be enough iron left over that the glass is going to wind up being a little bit green anyway, but it should wind up with some clear glass. That's what I'm hoping for. Whether or not we're able to actually make anything with the glass is still unknown, as it depends on how hot we can get it. If we can't get it hot enough to be able to work with, then we're not going to be able to make anything with the glass. But I'm fairly confident we'll be able to make the glass clear. If you guys want to see collecting the ingredients, such as the sand and the natron brine, go over to How to Make Everything's channel. There'll be a video there, and if you want to see the actual glass making, that's going to be over on Grant Thompson's channel. So, links will be in the description. Hope you enjoyed. I'll see you then. Alright. So we're at Grant's backyard now. We're preheating the crucible. We're gonna make some glass.